Before we dive into code, let's answer a question every beginner has. What does a Salesforce developer actually do all day? Picture a house. An admin is like the person arranging the furniture, painting the walls, deciding which doors are locked. And they do all of this just by clicking around, no code involved. A developer is the contractor. When the family says, we want to knock down this wall and build a custom room, that's too complex for furniture arranging. That needs someone who can build. That's exactly when a developer steps in. So practically, what does a developer spend their day on? Writing Apex triggers and classes, code that runs automatically when something changes. Building Lightning web components, custom screens people actually click on. Connecting Salesforce to outside systems like a payment gateway. Running batch jobs overnight for big data tasks. Writing tests and safely deploying changes. And constantly working alongside admins and architects. A developer is almost never working completely alone. Here's why this course is structured the way it is. The security model you learned earlier, that's why your Apex code needs to respect permissions. SOQL, SOSL, and DML? That's your daily toolkit. Nearly every single Apex class touches the database using exactly what you already learned. And the advanced Apex concepts like wrapper classes, that's what separates messy code from clean, professional code. Now, let's get into the single most common real task a developer touches every week, triggers.
Imagine a doorbell.
It doesn't ring on its own. Someone has to press it first. A trigger works exactly the same way. It doesn't run on its own. Something has to happen to a record first. There are only 4 things that can ever press the doorbell. Insert when a new record is created. Update when an existing one changes. Delete when one is removed. And undelete when one is restored from the recycle bin. That's it. Every trigger you'll ever write reacts to one of these 4 events. Now here's something that confuses almost every beginner at first, so let's make it simple. Imagine you're getting ready to leave the house. If you notice your shirt is wrinkled, you fix it yourself. Right before you walk out. That's before. Nothing else needs to know. Now imagine you've already left and arrived somewhere, and then you text a friend to say you've arrived. That's after. Because the action already happened and now you're telling someone else about it. In Salesforce, before triggers run before the record is saved, perfect for fixing fields on that same record. After triggers run once the record is already saved and has its ID, perfect for updating other, related records. When your trigger runs, Salesforce hands you a few special variables so your code knows exactly what's going on. Trigger.new gives you the new, incoming version of the record. Trigger.old gives you what it looked like before the change, so you can compare them and see exactly what was edited. And Trigger.isInsert, isUpdate, isBefore, isAfter, these simply tell your code which situation it's currently in, like little flags your code can check. Let's look at the actual skeleton every trigger is built from. You write the word trigger, give it a name, usually object name trigger. Then say on, and name the object it's watching, like patient _. Then in parentheses you list which events to react to. Everything else, your actual logic, goes inside the curly braces. That's the entire shape. Every trigger you'll ever see follows this exact pattern. Let's make this real. Imagine our hospital wants to automatically label any patient over 60 years old as senior the moment they're added to the system. No human needs to remember to do this manually. We write a before insert trigger. Inside, we loop through every new patient being created, check if their age is over 60, and if so, we set their category field to senior right before the record is even saved. Why before insert and not after? Because we're only changing a field on the same record that's about to be saved. There's no need for an extra save, which makes this version faster. As your trigger grows more complex, here's a habit that separates beginner code from professional code. Don't write all your logic directly inside the trigger file. Instead, keep the trigger almost completely empty. It should just say, hey, something happened, go handle it, and send the real work to a separate class called a handler. This makes your code easier to test, easier to read, and easier for a teammate to understand 6 months later. Here's one of the most important habits you'll ever build as a developer. Salesforce can run your trigger with up to 200 records at the exact same time, not just one. So if you write a database query inside a loop, and 200 patients are being processed, that's 200 separate queries, and Salesforce only allows 100 per transaction. You'll crash instantly. The fix: always pull your data with one query placed outside the loop before you start looping. Whether you're processing one record or 200, it stays just one query. This habit is called bulkification, and it's non-negotiable in real projects. Let's clear up some confusion about timing. When you save a record, Salesforce runs through a specific sequence. First, basic system checks. Then, your before triggers run. Then, validation rules. Then, the record actually gets saved to the database and receives its ID. Then, your after triggers run. Then, automations like flows. And finally, everything gets committed for good. This explains exactly why before triggers can edit a field for free. The save hasn't happened yet, while after triggers need a brand new, separate save if they want to change something. Here's a tricky bug every beginner runs into eventually. Imagine an after update trigger that updates the very same record it's reacting to. That update triggers the trigger again, which updates the record again, which triggers it again. This is called recursion, and without a safeguard, it can loop dangerously or just silently waste resources. The fix is simple. Create a static Boolean variable, almost like a sticky note that says, "I've already run once." Check it before running your logic and the loop stops immediately. Remember when we talked about multi-tenancy? Many companies sharing the same Salesforce servers? This is exactly where that shows up in your daily coding life. You get 100 SOQL queries per transaction, 150 DML statements, a max of 50,000 records pulled back at once, and just 10 seconds of processing time. Every single best practice we just covered, bulkification, no SOQL in loops, recursion control, exists for one reason only: to keep your code safely inside these numbers. Now here's something exciting. Everything we just learned about Apex triggers has a visual, no-code version, and it's called a record-triggered flow. The idea is identical. A record changes, say a new patient is created, the flow runs automatically, checks some conditions, and takes an action like updating a field or sending an email. It's literally a drag-and-drop version of what an Apex trigger does in code. No typing required. A screen flow is different from every other flow type, because it's the only one a real person actually clicks through, step by step. Imagine a receptionist registering a new patient. Screen 1 asks for the name and age. Screen 2 asks which department they need. Once they finish, the record gets created automatically behind the scenes. It feels like filling out a simple form, but it's actually a full Salesforce automation running underneath. A scheduled flow doesn't wait for someone to click a button or change a record. It simply runs by the clock, like an alarm. For example, every night at 2 a.m., find every appointment scheduled for tomorrow and automatically send a reminder email to each patient. Nobody has to remember to do this. It just happens every single night on its own. An auto-launched flow has no screen and no schedule. Instead, it waits to be called by something else. That might be a button someone clicks, a line of Apex code, or even another flow. Think of it like a reusable helper that other automations can call into whenever they need that specific piece of logic done. Just like Apex, flows have limits and habits worth following. Try to keep just one triggering flow per object per event. Too many overlapping flows get impossible to debug. Avoid fetching records inside a loop for the exact same reason as Apex. And name your elements clearly. Decision is senior is far more helpful than decision 1 when you're staring at this flow 6 months from now. And here's the one big question to always ask yourself. Should this be a flow or should this be Apex? If the logic gets complex or you're processing large amounts of data, Apex usually wins.